Hello students. All right, so in the first video, part one of this series on Sage with the Fourier series, I let Sage compute the Fourier series of this step function. Now, let's say that you actually computed the coefficients on your own, and you found that a0 was 1/2, and that an was equal to 0, and bn was equal to 2 over n times pi. Um, and you wanted to define that to be the case. So let's say you're saying that this is going to be a Fourier sine series. Um, then you want to define this function. So the way that you do that is first we have to define the variables in Sage. I believe x is a default. But let's say I just want to define the x variable anyway. So to define for Sage so that it knows that these variables are coming, and how to treat them, you have to put this var, and then in quotes here put the x, and then I'm going to use I as an index and n as another index. So I do that, and then to define functions, it's very much like in Python. You do def, in fact I think it is Python, b n is your input, and then you're just going to return the 2 over n pi that we said it was here. And then so if I do that, okay, so I've defined the Fourier coefficients using an inline function, and then if I define the function, it'll be 0.5 and then plus the sum, then the Fourier coefficients times the sine function, and this is the respective frequency content, so it's only odd um, possibilities, and so I'll define it that way. And then if we wanted to output the function, it would look something like that. And then if I wanted to plot it, I would get something like that. And oh, I see. Yep, I must have defined a different function. Yes, this is 0 from minus pi to 0 and 1 from 0 to pi. That was my function. So um, so that's what the function looks like. And here I am. I'm plotting 0 from pi to 0 plus 1 from x is 0 to pi. So this function is a different one than the first video. If we were to do it in the first video, we'd have to compute I would have to go back here and define my piecewise function a little bit differently, and I can let Sage do that. But anyways, here's another example just for some variety. This is a sine series. So here I had a slightly different function. It's a step function that from minus pi to 0 is 0, and from 0 to pi it's 1. And then of course I computed these beforehand. I computed these Fourier coefficients, and if I want to increase the number of terms, of course, as I increase the number of terms, takes a moment, I get a better and better approximation. But once again, you have these discontinuities, and it wants to converge to the midpoint, to the 0.5, and it's having trouble resolving that. But it'll get very flat away from the boundaries. So anyways, that's those are another example of a way that you can use Sage to create these plots and to construct your Fourier series as well. And if you just wanted to see what the function looked like on its own, let me just copy and paste this part of it. Here, maybe I'll put it right here. There we go. Shift Enter, and that's what the function looks like. And I can it's great. You can overlay plots by just adding them. And then if I want to overlay, I can, the Fourier series on top of that, I can do plus. I did that differently in the previous video. In the previous video, I used this show command. and this was a cosine series. Oh, and I'm glad I did. Yes, right. I'm glad I did these two examples. I wanted to show you also that notice that with the discontinuities, with the discontinuous function, piecewise function here, it's symmetric about the y-axis, so it's only a cosine series. So all the you could tell just right now that all the sine terms, the coefficients of the sine terms are going to be 0, and all the coefficients of the cosine terms will be non-zero. In this case, all the cosine terms, which must be the an's, except for the first one, are 0, and all the sine terms are non-zero, and that's because you have an anti-symmetric function. And this looks like the sine. So if I only did, let's say I did maybe 2 terms. Yep, you can see that right there. That's only let's see, can I get away with 1 term? I should be able to. Yep. So there it is. There's the sine function. That's the lowest frequency content, and then I can get up to the highest. I can get up some pretty high frequency content. Let's see if I can get Sage to do this in a timely fashion. Giving it 50 terms. It's taking a while, and it's thinking, oh, it did it. Okay, not too bad. And there it is, the Fourier sine reconstruction of this this signal that switches off to on, off to on. And like as if you're sensing that signal and you wanted to reconstruct it with this frequency content, the arguments of the sines, and each of the terms gets weighted. And you can notice that as you increase the frequency, notice that the coefficients start to decrease, and in fact they'll decay towards 0 eventually, and that's what allows you to have a convergent series, by the way. All right, have fun using Sage, and good luck.